Bismillahirrahmanirrahim. In today's lecture, we are solving problem 1-59 from the book Thermodynamics and Engineering Approach by CENGEL 7th edition. So, the statement is the piston diameter in figure P158E. This is figure P158E. D1 is equal to 10 centimeter. This is D1. D1 is equal to 10 centimeter and D2 is equal to 4 cm. This is D2. This the chamber of this diameter. The diameter of this chamber is 10 centimeter and diameter of this chamber is 4 centimeter. When the pressure in chamber 2 is 2000 kilopascal, here pressure P2 is equal to 2000 kilopascal, and the pressure in chamber 3, this is chamber 3, here the pressure is 700 kilopascal. What is the pressure in chamber 1? Point pressure in this chamber. So first I write given data. So in given data, we know that diameter of chamber 1, diameter of chamber 1 is equal to 10 centimeter, and for conversion into meter, divide this value by 100. So 10 divided by 100 meter, which is equal to 0.1 meter, and diameter of chamber 2 is equal to 4 centimeter. Convert this into meter, which will be equal to 4 divided by 100 meter, which is equal to 0.04 meter. So when the pressure in the chamber 2 is 2000 kilopascal, pressure in chamber 2 is equal to P2 is equal to 2000 kilopascal, and pressure in chamber 3 is equal to P3 is equal to 700 kilopascal. What is the pressure in chamber 1 in kilopascal? Required is find pressure in chamber 1, P1 in kilopascal. So in solution, first we show the equilibrium force diagram. So we know that P2 and P3 and down there is a piston cylinder arrangement. So P2 and P3 pressure will be in the downward direction. This is P2 and this is P3 on this ring. P3 is on this ring. This is P3, and P1 is in upward direction. So if we take an equilibrium condition in y direction, so from equilibrium conditions in vertical direction or y direction, upward forces will be equal to upward forces will be equal to downward forces. We know that PA is equal to force, pressure multiplied by area is equal to force. So upward force is P1, and P1 is on this area. P1 is on this area A1. So P1 A1 is equal to downward forces P2 A2. P2 is on area A2. This area is A1 and this area is A2. P2 A2 plus P3. P3 is also in downward direction. And area for A3. Area, this total area, this total area is A1. But P3 is on this area minus A2 because the area of this piston, this region, and the area of this chamber are equal. So this force, this pressure is on this area multiplied by A2. I will subtract this area from the total. So I will write P3 A1 minus A2 because this is chamber 1, this is chamber 2, and here the area, this area is A2, this total area is A1, and this area is A2. So if I calculate the area for P3, this is P3, pressure P3, so I will subtract A2 from A1 because this A2 and this A2, both area of these are equal. So I will subtract A2 from this total area. So the area for pressure A3 P3 will be equal to A1 minus A2. I will subtract the area of this. So this will be equal to P1 A1 is equal to P2 A2 plus P3, and this is the equilibrium condition, and vertical direction upward forces will be equal to downward forces. So we have to find A1. So first I find A1 and A2. First we will find A1 and A2. A1 and A2. So A1 is equal to pi by 4 d1 square, which is equal to the value of pi is 3.14 divided by 4 multiplied by 0.1 meter whole square. So A1 will be equal to, if I calculate this, A1 will be equal to 0.00785 square meter. A2 is equal to pi by 4 d2 square, which is equal to 3.14 divided by 4 into 0.04 meter whole square. So A2 will be equal to 0.001256. Now I can easily find P1 from the above equation. P1 A1 is equal to P2 A2 plus P3 A1 minus A2. So both are divided by A1. A1 will be cancelled, and here P2 A2 plus P3 A1 minus A2 divided by A1. Putting values, so P1 is equal to, P2 is equal to 2000 kilopascal multiplied by A2 is equal to 0.001256 square meter plus P3 is equal to 700 kilopascal, and A1 minus A2 A1 is equal to 0.00785 minus 0.001256 square meter divided by A1, and A1 is equal to 0.00785 square meter. Further simplifies it, multiply 2000 by 0.001256, which is equal to 2.512, and unit is kilopascal multiplied by square meter, plus 0.00785 minus 0.001256 and multiply by 700. So this will be equal to 4.6158. Unit is kilopascal square meter, divided by 0.00785 square meter. Now P1 is equal to, this unit is kilopascal square meter and this unit is also kilopascal square, so we can add these two values. 2.512 plus 4.6158 is equal to 7.1278 kilopascal into square meter divided by 0.00785 square meter. This square meter will be cancelled by square meter, and this division will be equal to 908, and unit is kilopascal. So pressure in chamber 1 is 908 kilopascal. And for more problems, please like and subscribe my YouTube channel. Thank you.